Our fourth lesson in Unit 3 focuses on glide reflections, and this is essentially a composition of a translation and a reflection. And so we're going to try to work through this in sort of hopefully a quick manner. There will be a couple items I'll have you do, a couple items that I will do. Remember, on the ones that I ask you to do, your job is to try to do it. If it ends up incorrect, not a problem. We'll correct it in class. You'll still get the credit for it. The only way you lose credit is if you don't actually try to do the item. So let's make sure that we do that. Our goal is to make sure that we can identify these rigid motions that are used to transform our two-dimensional figures. And so along with that, we're thinking rotations, reflections, translations, etc. And specifically, how do we move in some sort of composition of transformations, all right? Composition of rigid motions, all right? So with that in mind, there are a few things that we have discussed, but not overtly. And I want to make sure that we address these two things that were part of our previous lessons, but not formally addressed. I know that when you hear the word theorems, you're thinking about proofs and you're thinking about logic, and I know that we've had our stressors over the past couple months with that. Our next unit, I feel like the proofs that we do will be, first of all, we're going to get a ton more practice with it, but also there'll be a lot more straightforward perhaps than you've maybe experienced them thus far. That being said, with the practice and work that we do in the next unit, we're going to get so strong at our geometric proof that we'll look back on our old proofs and say, oh my gosh, these are easy, I can do these, I can handle these. So with that, here are 4 theorems that address the content of these 4 units. First of all, a translation is a composition of reflections across parallel lines. We discerned that, we understood that in our lesson 2 practice and lesson. And so this is a key concept that I want to make sure you understand. Any rotation is a composition of reflections across 2 lines that intersect at our center of rotation, our point of rotation. And so with that, that was basically our last example on the lesson 3 notes. And then here are 2 ideas that we are going to discuss today. Number 3, theorem 3.3, the composition of 2 or more rigid motions is a rigid motion. We kind of understood that when we did our rotations and said that it's the same as 2 reflections, when we did a translation and said it's the same as 2 reflections. And so hopefully if you are doing a rigid motion and then another rigid motion, even if you're doing another rigid motion and another rigid motion on top of that, obviously as you do those, sorry for the bell, as you do those, you'll notice that we are maintaining the same size, maintaining the same shape, maintaining the same angle measures as we execute those motions. Any rigid motion is either a translation, a reflection, a rotation, or a glide reflection, all right? And so these kind of go together in the way that they articulate that every composition is a rigid motion, every rigid motion is either a straight rigid motion as we've described or a composition of rigid motions. And so these are the options as we navigate through these rigid transformations, okay? So with that in mind, here is what a glide reflection refers to. A glide reflection is simply where we do a reflection and then a translation. Or we do a translation and then a reflection. There's a little bit of commutativity there that we're going to try to address. Does the order of the composition matter? You're going to answer that question hopefully by the end of our conversation here today. And so again, when we reflect over line M, we get this gray triangle from triangle ABC. And then when we translate that reflection to the right 4 spaces, we now have our new triangle A prime, B prime, C prime, all right? So this is a reflection and then a translation, all right? That is what a glide reflection refers to, a composition of a translation and a reflection. Is there a series of rigid motions that can change triangle ABC to triangle A prime, B prime, C prime? The answer to this is yes. And so let's do our best to write that composition. So here's what we're going to do. We are going to do a couple things. We can reflect this along a vertical line, and it kind of doesn't matter which vertical line we choose, all right? So I could reflect it over this vertical line. I could reflect it over this vertical line. I could even reflect it over this vertical line, or I could reflect it over this vertical line. I have lots of options where I can reflect that. In order to make this as kind of straightforward as possible, I'm going to reflect it over the line x equals -1. When I reflect it over the line x equals -1, I'm going to move point B 2 spaces on the other side of that line of reflection, point C 2 spaces on the other side of that line of reflection, and then point A 4 spaces on the other side of that line of reflection. All right? When I do that, use my ruler here, I get this new figure. And then I'm going to translate that down. I'm going to translate that down 1, 2, 3, 4, 5 spaces. All right? Now I'm going to translate that down 5 spaces. All right? Down 5. So let's write this as a composition. Our first translation was to reflect. So we're going to reflect over the line x equals -1, triangle ABC. But then we're going to translate that reflection. So I'm going to go back, I'm going to draw my open circle for our composition, and we're going to translate to the right or left nothing, but then up or down, we're going to go -5. This is the composition of translations, or of rigid motions, that execute this glide reflection to get from triangle ABC to triangle A prime, B prime, C prime. Now, I did say that we could maybe execute that a little bit differently, so I want to show you maybe another way in which we could do the same thing. This is kind of the easiest to say, let's get this over here so it lines up, and I just drop it down 5 spaces. But I did say, what if I were to reflect this over the line x equals -3? What if I reflected it here, where I just kind of flipped this picture over? What that does for us, when I reflect that over the line x equals -3 of triangle ABC, is it gives us a new triangle that is oriented the same direction as our end result. But our translation is now going to be a diagonal translation, and we have to make sure that we can get over there. We are still going to go down, how many spaces? 1, 2, 3, 4, 5 spaces. But then we need to go to the right, 1, 2, 3, 4 spaces. All right? So if I'm reflecting over this vertical line, then I would need to translate that to the right 4, down 5. And this would be the composition of rigid motions that is going to get us our glide reflection. All right, so on this, here's the thing that's a little bit interesting and maybe complicating, all right? And hopefully it's not going to complicate things too badly, but sometimes there are multiple ways, or oftentimes there are multiple ways to write our composition. If you need to watch either of those examples again, pause it, review back, watch it again, and see where I confuse you or where that gives you trouble, all right? What if we change the order? What if I do the translation first and then I do the reflection? So this question is, does the order matter? And when you're doing translations or reflections, well, we're going to find out here that in this particular case, maybe it doesn't. If I move this down 1, 2, 3, 4, 5 spaces, then I get this triangle. And then if I reflect that triangle over the line x equals -1, it is going to become that triangle. So if I change the order here, this is the same thing the reflection over the line x is equal to -1 of the translation to the right 0 down 5 of triangle ABC. All right? So this composition, in this composition of translation and reflection, the order does not matter. All right? We say that that is a commutative composition. You might remember the commutative property for addition and the commutative property for multiplication, saying if I take 2 plus 3, I get the same as if I do 3 plus 2. If I take 2 times 3, I get the same as if I do 3 times 2. That's the commutative property. Well, here with these compositions, these are commutative. All right. Here we're going to execute a glide reflection, all right? We are going to follow the rule that's given here to translate 1 to the right, up or down 0 of the reflection over the y-axis. So first I'm going to plot these points. Negative 3, 2, 0, comma 5, let me count correctly, good. 4, comma negative 4, and 0, comma negative 2. All right, so this is my quadrilateral, and we're going to do a couple things. First, we are going to reflect this over the x-axis, which is the equation y equals 0. It's a horizontal line. So we're going to be flipping this vertically. Flip it vertically over the x-axis. When I do that flip, it is going to give me this picture. All right, so I should probably label these so that you can follow along. This was R, S, T, and V. And when I flip those, I end up, this is the line y equals 0, and I reflect it over that line. This is 4 spaces, now it's going to be 4 spaces for t prime. This is 5 spaces, it's going to be 5 spaces down for s prime. This was 2 spaces down, now it's going to be 2 spaces up for v prime, and r is going to be down here, r prime. I'm going to redraw this so you can see r prime, s prime, t prime, v prime. I'm not very fast with my ruler, I apologize. We should be able to follow that. And then our translation is just to the right one. So we're going to take that black image and we're going to move it to the right 1 space to get our end result. All right, now here's what's important to note. It is important that we can visualize the end and know where the end actually is. And so for some situations, we may not need to draw this secondary picture, all right? And we can call our end result the prime result, right? T prime, V prime, this one was R prime, and this one was S prime. All right? And so this is a glide reflection. We glide it and flip it, or we flip it and glide it. I would like for you to try to execute this one. Plot those 3 points. I'm just having you do 3 instead of 4. And I would like for you to do this reflection over x equals 0 and translate it back 3, up 4. All right, go ahead and do that one. Pause the video. Write the glide reflection that maps this one. Okay, we've already kind of done an exercise like this. This one's a little bit more complicated, and so let's kind of do our best work here. But we want to try to visualize what this looks like if I translate this first. Now I'm just going to do a J prime, L prime, K prime. That gets us over here. Gets us to visualize this situation. And then I need to flip it. So when I'm flipping it, the translation is easy. We can see that we went 1, 2, 3, 4, 5 spaces. All right? But when I flip it, how can I tell where my line of reflection is? Well, it's obviously a horizontal line of reflection. Sorry if it's a messy board there, if you're having trouble seeing that. But the way that we find out where that line of reflection is, we know it's horizontal. Let's find the midpoint here. 1, 1, 2. This is our line of reflection, which is the horizontal line, y equals positive 1. Okay? When I flip this, I'm going to move this 3 spaces, 3 spaces. I'm going to move this 3 spaces, 3 spaces, 2 spaces, 2 spaces. It works out just fine at y equals 1. We can find that using the midpoint formula. What's the midpoint between these two? And go from there. If this is on a diagonal, which so far these haven't been, so I don't think we have to stress about that, we could use the midpoint formulas for several points, J prime and J double prime, K prime, K double prime, and then use our slope formula and then our point slope formula. So this is doing 2 things. It's a translation 5 to the right, 0 up and down, and then it's a reflection over the line y equals 1. So how do we want to organize those? Well, we just said a couple slides ago that the order doesn't really matter. If I flip it and then slide it, That's going to give me the same thing as if I slide it and then flip it. So it doesn't matter what order you write these in. You can say t of 5, 0 of the reflection over the line y equals 1 of triangle JKL. Or you can say the reflection over the line y equals 1 of the translation of 5 to the right, 0 up and down of triangle JKL. Is going to give us JKL. All right. Hopefully that went well for us. Hopefully we're doing all right with that. I would love for you to try to do this one. Let me erase the picture that I drew before so that you can see clearly. I don't know why this isn't erasing very well. Might need a new eraser. This one's probably about 4 years old, so apologize for that. Go ahead and see if you can write the rule for this one. Pause the video as needed. And this is one that you do. And then that is the end. I can identify different rigid motions used to transform two-dimensional figures. Please post any questions that you have in Google Classroom, or email, or visit during seminar.